this video, I'm going to go over how to set up problem number 3 on the Chapter 12 problem set. The problem says, imagine the Earth is on the surface of a sphere whose radius is equal to the distance between the Earth and the Sun. This is 1.5 times 10 to the 11th meters. If the total radiant flux from the Sun in watts, calculated from the last problem, is evenly distributed over the surface of this imaginary sphere, what is the average flux in watts per square meter? So in setting this problem up, you really just need to imagine this imaginary sphere. Here it's shown by this black circle, and obviously this is a two-dimensional representation of a three-dimensional problem. So here we have this imaginary sphere, and the radius of this sphere is the same as the distance between the Sun and the Earth. And in the last problem, you calculated the total radiant flux that is leaving the Sun, or is emitted from the Sun, and this radiation is emitted in all directions outward from the Sun. So what this problem is asking you to do is to calculate the amount of radiation that is reaching the outer edge of this sphere in watts per square meter. So in order to calculate this value, all you need to do is to divide the total radiant flux in watts that you calculated in the last problem by the surface area in meters squared of this larger imaginary sphere. And the average flux value that you get when you do that will be equal to the amount of radiation that is received here at the Earth's equator by this direct line from the Sun to the Earth's atmosphere. So your average flux value will tell you the amount of incoming solar radiation that is received at the Earth's atmosphere.